Hi, my name is Rogelio,
And my name is Ian.
and we are the Roboboat team leaders this year. After 2 years of lockdown and competing online, we are excited to be back in campus this semester and finally be working in person on our boat.
Thanks to the constant development made on the boat system during the last year, we are confident in our path following and collision avoidance capabilities. We have a consistent detection system for props with simple dimensions.
We currently have approaches for the mandatory navigation, avoid the crowd challenge, snack run challenge, and find a seat in the show challenge. These were proposed in simulation using Gazebo for last year's competition.
This year, we focused on validating in a real-world environment the solutions presented in previous competitions. Although we were met with a handful of problems, we were able to handle most of them. Hi, I'm Sebastian, I'm VantTec's Vice President, and I also provided general support for this competition. We also faced some loss of knowledge on the perception team as people graduated and moved on. So the software was available, but some systems were not touched for a while because there was no one that knew how to use it.
With these constraints in mind, the strategy this year is focused on giving priority on testing the now called avoid the crowds, snack run, and mandatory channel challenges, as the solution only need to be validated in the physical test. On a second level, we plan to improve the final stage of the show as it is based on the acoustic docking challenge and develop a scalable solution.
Contrasting to previous competitions, this year we can rely on waypoints to initiate our state machine-based algorithms. To solve this problem, we developed a registry of the obstacles positions the boat detects during the complete mission run, and another node that runs at a lower frequency that takes the registered obstacles and identifies which cluster of obstacles belong to each mission task, returning a waypoint that defines the beginning of each task that is sent to our challenge algorithms.
Hi, I'm Abiel, and I'm the Electronics and Embedded Systems team lead. For this year, we focus on further developing our electronic system in order to support the mechanisms that we created in order to solve the challenges. For this, we developed 2 new PCBs, a power distribution board and a controller board. With these, we can safely power and control up to 60 motors if needed. This makes it so that our electronics system is future-proof and can be reused in other applications, such as our autonomous submarine for the RoboSolve competition.
My name is Max, and I'm part of the electronics and software teams. Our algorithm first detects the main gate and initiates the state machine, detecting buoys in parallel position and labeling them as gates at the front of the boat, creating a waypoint to advance. When crossing a waypoint, it goes back into a searching state until it detects another gate ahead. If a gate does not appear after a certain distance, the task is deemed as completed.
Hey, I'm Alexa and I'm part of the perception team.
The final set of the show challenge is based on the solution proposed for acoustic docking for last year's competition. We considered that this challenge was simplified as we have not made enough progress yet with our acoustic detection system. The main change is the selection of the gate to get into, which is now independent of vision and not our detection.
Hi, my name is Javier, and I'm a part of the perception team. Last year, we detected the dock using LiDAR point clouds. For this year's approach, we plan to implement classical computer vision, so we can detect the color and shape of the docking bay symbols, and then set a waypoint so our control system can navigate towards it.
The snack run challenge is also one of our most consistent challenges. For detection, we use the object registry node, and it functions similarly to the avoid the crowd challenge. When detecting the gate, it creates a set of waypoints perpendicular from the gate that it follows until it detects the marker to circumnavigate around. Thereafter, to navigate around the marker, the algorithm creates waypoints around it that are sent to the control systems and finally return to the initial gate, the initial waypoint. As time is important in this challenge, the state machine in this challenge removes the movement limit put on for safety measurements, specifically when traveling in a straight line.
Saving the best for last, I'm Mauricio and I'm the Roboboat Mechanics team leader. The ski ball game was just introduced this year and it was a big challenge for the team. We had to design and fabricate a mechanism that shoots the ball with enough power while staying safe. We added a pan and tilt mechanism to allow the shooter to aim for the frame because the ball has to go through it for it to count.
I'm Rodrigo, and I'm part of the mechanics team. We also had to work on creating a prop with a proposed dimension, and a visual aid for the assistant to locate and aim at the task, which in this case we are a purple frame and orange circles around the targets.
And this is what we plan to do. See you at the competition.